Hello everyone, this is Steve. Thanks for joining me. We are going to graph the parabola associated with this quadratic right here. So the first thing we observe about this quadratic is that the number in front is 2, which means we know for sure the parabola is going to open up. And we also know, like we know with every quadratic, that our domain is going to be negative infinity to infinity. The most important point on any parabola is going to be its vertex, and fortunately because our equation is written in the form it is, we can just read the vertex right off the equation by looking at this number here and this number here. The only hiccup with this is you have to remember that the value on the inside is the x value of the vertex and the value on the outside is the y value, but you got to switch the sign on the x value, just like a horizontal shift. So the vertex is actually going to be at -3, and then the y value is fine the way it is at -8. Once we have our vertex and the direction that our parabola opens, we actually can give the range, because this particular one we can see is going to go up forever to infinity, but its lowest value is going to be the y value of the vertex, which is going to be -8. Okay, we can also write down the axis of symmetry now that we have the vertex. Axis of symmetry, which is always going to be x equals, and then the x value of the vertex, -3. So already we have quite a bit of information. Next thing we're going to need is the Y-intercept. Careful with the Y-intercept, because a lot of people think that the Y-intercept is just going to be the number at the end of the equation. They just think it's going to be just -8. But it's not going to be that -8, because the Y-intercept is found by plugging a 0 into the function. And when you plug a 0 into this function right here, you will notice that the 0 does not eliminate everything except for the -8. In fact, we get a 0 plus 3 here, which is 3, and 3 squared is 9. So we get 2 times 9 minus 8, 18 minus 8, or 10. So our y-intercept is actually 0, 10, even though we couldn't see that 10 in the equation before. All right, next thing to do is find the zeros. So what I'll do is I'll take my quadratic and set it equal to 0. We'll do that over here. So we've got 2x plus 3 squared minus 8 equals 0. The cool thing about finding the zeros when your quadratic is in the form that it is here is that completing the square has already been started. So we just kind of finish the process of completing the square. I'm going to add an 8 to both sides, everyone. And then I'm going to divide both sides by 2. Apply the square root property, take the square root of both sides, and you're going to get square root x plus 3 squared equals plus or minus the square root of 4. Let's clean that up. X plus 3 equals plus or minus 2. Go ahead and subtract a 3 from both sides, and you will get your zeros are -1 and -5. Those are real numbers, so we can turn them into x-intercepts. It's going to be -1, 0, and -5, 0. All right, that is all the information we need to go to the graph. So let's go ahead and sketch the graph. Okay, so the first point I'm going to plot on my graph is going to be my vertex, which is at -3, -8. That's going to be right here. You can go ahead and label that. I'll also plot my x-intercepts, which are going to be -1, 0, and -5, 0, 2, 3, 4, 5. And I'll plot my y-intercept, which is way up here at 0, 10. Now, if I sketch the axis of symmetry, which I'm doing right now, you can see that the x-intercepts are equal distance from the axis of symmetry, like they should be. But the y-intercept also has a mirror image point on the other side. So the y-intercept is at 0, 10, which is 3 units away from the axis of symmetry. So if we go 3 units away in the other direction, we get another ordered pair at -6, 10. That's going to help us draw our parabola. The other thing you can do is you can always find extra points just by plugging x values into the function. For instance, if I take my original function and I plug in a -2, or if I plug in a -4, both of those actually give a value of -6. You can check that for yourself, but that gives me 2 extra ordered pairs right here and here. Okay, so let's go ahead and draw our parabola. So, nice smooth cup down there, coming up there like that. Coming up there like that, and here goes nothing. Let's see if I can do this. Not so bad. Okay, that one's kind of hard to draw because it's kind of skinnier than some of the other ones we draw. But using all this information up here, we're able to sketch this parabola you see here. Okay, thanks for watching. I hope that helped.